Okay, we are on week 6 tutorial. We have 6 questions and 30 to 40 minutes. So the first question, the length of 3 rods. This one, the vertical one is C. This one is B, and the other one is A. So find the center of mass for each of these 3 rods and just draw the vector gravitational force, which is mg or rho bg. Why we say rho bg? B is the length because rho is the mass density per length. Or kg per meter. So we need to find the moment of these 3 vectors about point O. But at point O, we have a welding point. It means that we have OZ, OY, and OX, and MX, MY, and MZ. You can show this vector MX by another way I will teach you. Okay, some people show MX like this. They put 2 arrows at the head instead of this curved vector. So it's up to you. Most of the time I use this 2-headed vector. So at the welding point, we need to draw OX, OY, OZ, and MX, MY, MZ because it is a welded junction. And these are the reaction forces and reaction moments. So you need to draw the line of action at these points. How can we do that? We can just draw the line of actions, and moment about point O means the distance times F, which is rho bg times this length, which is b over 6. So this is b over 6 j, the vector, and moment arm actually, and rho bg, actually negative rho bg k, is the force vector. And you do the cross products and you will find rho bg b over 6 but negative. This is the moment about point O. And we also have mx. So this is the summation of mx. For summation of my, we need to also find the moment of all of the forces about point O. So rho cg about point O, the line of actions actually passing through O. So it means that the moment of rho cg about point O is 0. But what about rho ag? The distance between the line of action and point O is a over 4, because this length is 3a over 4. So a over 4 times rho ag, and my is the other moment at y directions. So we have this equation, and this equation. We find mx, my, mz, and we know that the summation of fx, fy, fz is 0. So we get, let us see and find the force vector that is directing in z direction. So negative rho bg, negative rho ag is in, these are in z axis, and rho CG and OZ. So I write all of them. Just be careful, these are negative and the only one is positive, OZ. Okay, you might ask why OZ is positive. It's up to you, but I always ask people to put the unknown in positive directions. It's easier. So we find OZ, rho G, A, B, C. They will be to the right hand side, and you will find OZ. And the magnitude of the O, the magnitude of the force at this reaction force at this point. Reaction force means OXI O plus OYJ plus OZK will be this. And also remember, mx, my, mz are the component of m vector. So we need to find a magnitude like this. And this is the final answer. So we have in the next question, we have a uniform 15 kg plate. So 15 kg, you find the center of mass, which is the center of this rectangle, and it is downward. So you just type or write 15 times g. And supported by bearing A and B. These are two bearing. Calculate the magnitude of the force supported by bearings. You might ask, what is bearing? Let me show you what is bearings. Okay, these are called bearing, okay? The shaft goes inside. Look at here. This is a shaft that goes inside of the two bearing. So calculate the magnitude of the force supported by bearing B during application of the 120 Newton, that's meter. So it means that this one is coupled. We have a 120 Newton meter couple here at this axis. It is rotating this shaft. How? Maybe we just apply, we just connect this shaft to a motor and it will rotate this shaft. So the cable from C to D, prevents the plate and shaft from turning. So we have another cable, so we have a T here, so we can just resolve it into Tx and Ty. And the weight of the assembly is carried entirely by bearing A. So it means that at A, we also have AZ. But here we don't have anything because it says that all of the weight are carried by AZ, we don't have BZ. Otherwise, some part of the weight might be taken by BZ and bearing B. So let us write down the equations. So 120 Newton equilibrium of momentum at z-axis. We want to find summation of mz, mx, and my. We know that it is equal to 0. So you can also do another thing. You can find the moment of all of these forces about point O origin, okay? And then the result will be mxi plus myj plus something mzk. And then you can put it equal to 0. So let us do that. 120 Newton, the direction of this moment is in the z direction. What else? Tx times this length, which is 600 millimeter, or 0.6 times Tx, negative, equal to 0. So what about the moment about x-axis? By times this length and ay multiplied to this length, and w times 600 over 2. But make sure that you just convert it to meters. So it will be 0.3. 600 divided by 2 will be 300. 300 millimeter is 0.3 meter. So W times 0.3, it is negative. And also about the y-axis, we find the B like that. After finding BY and BZ. Okay, next question. We have a vertical force P on the foot pedal of the bell crank. So we have a tension T here. It is 400 Newton. In the vertical control rod, determine the corresponding bearing reactions at A and B. So we have negative P and negative 400. The summation of the forces in z-axis. I forgot to put z-axis, but it doesn't matter here because we don't have a fx and fy. So we just put fa and fb in vertical direction and upward. We assume that they are positive, both of them. So it will be fa plus fb minus p minus t equal to 0. And then find the moment of all of these forces about point O. Then you can divide it to an x, m summation of mx, summation of my about point O. Then your answer will be like this. Determine the force in each member of the loaded truss. So we have 5,000 newtons here. Let us write down the equilibrium of node C. So we have BC here, and we have DC here, and we have 5,000 newtons. 5,000 is downward, and CD is that way. And you can assume that BC is this way, okay? And then write down the equation in X and Y. So simple. It is like a 2D problem. So it will be BC cosine 45 minus CD. And in the Y directions, Y is the upward, minus 5,000 plus BC sine 45. You find BC and CD with two equations, two unknowns. And now we go to point D. We find CD from these equations, and we go here. So we assume that BD is acting this way, or AD is acting the other this way. And again, we find first you need to be very good at geometry. This is 55.12. Again, this angle will be 55.12, and this is 45. Therefore, this will be 45. And you write down the summation of fx, summation of fy, and you find BD and AD. So it will be CD minus BD cosine 55 minus AD cosine 45 equal to 0. For summation of Fy, this one doesn't have a Y component, so we have BD sine 55.12 and AD sine 45, but negative. With negative here. And we find again BD and AD. And now at point A, you assume that you have here you have AD, you also have AB, and at this point you have just FA. Why you don't have X directions at point A? Because we have 5,000 here, and this is also vertical. If you solve this for the whole body, you can find out that AX is equal to 0. It's better to change FA to AY. That's okay, we will solve it because it is from another tutor. So summation of Fx for this joint will be AD cosine 45 minus AB equal to 0. So we find AD. We have already found AD, sorry. And we plug it in here and we find AB. So the 72-meter structures is used to provide the various support services to launch vehicles prior to liftoff. In a test, an 18 mg mass is suspended from joints F and G. With its weight equally divided between the two joints, determine the forces in members GJ and GI. What would be your path of joint analysis for members in the vertical tower, such as AB or KL? So 18 mg is the mass. G is not 9.8. It's not a acceleration. It doesn't have acceleration unit. So it will be mega means 10 to the power of 6. For example, have you heard about megabyte or gigabyte? Mega means 10 to the power of 6. So the mass is 18 times 10 to the power of 6 gram. So we will divide, how much is the weight, the force? So we will multiply this to G and divide them by 2 and again by 1000 to change it to kilonewtons. So we find alpha, beta, gamma first. How much is alpha? So this length is 3 meters based on here. Also, we know that this length is also 3 meter from here. If you check it here, it is 3 meter, 3 meter. We have 6 section at 4.5 and it says that the last one is 6 meter because 12 section at 6 meter. So it means that from here to here is 6 meter. So therefore this will be 3 meter. Again, you need to be very good at geometry. So we'll find alpha, which is 45. And for beta, from here to here is 27. And this length is 3 meter. And for gamma, it will be 3.5 over 4.5. So we obtained alpha, beta, and gamma. Now we start from F. So F is here. So we have a force that is applied, which was the mass that was divided by 2, 88.29 kilonewton. And we have GH and also FJ or JF. And we have this angle. Again, we have two unknowns. We can find it easily. And now for joint J, we have the angle. We have JF from the previous section, 124.8. Then we use it here. Again, we have two unknowns. We find GJ and IJ. After finding GJ, we have to do it again for point G. We have HG and GF and GI, and this is GJ. We also have a W here. Yep. So we have all of them except HGI. And you might ask me, okay, we don't have HG2. You are right. We can also obtain HG from two equations, two unknowns, but we don't need to find HG. You can do it.